In this video, we're going to be finding x-intercepts or solving equations. And those two things really mean to do the same thing. If you're looking for an x-intercept, you're looking to see where the graph crosses the x-axis. And if you're solving an equation, it turns out that you're also looking to see where the graph of an equation crosses the x-axis. Here's why. If I draw a little sketch of a parabola, and I ask you to show me where the x-intercepts are, you're going to make a point here and mark a second point over here. That's where this graph of that quadratic equation is crossing the x-axis. If I asked you to solve the equation that went with that graph, you would be looking to see where that equation was equal to 0. Or where the y's were equal to 0. Well, those 2 points that we marked, their y-coordinate is 0. So say this was my equation, y equals x minus, well, let's see, x, make it pretty easy, x squared minus 1. That was my equation. I could graph it. I would see where it's crossing. If I wanted to find the solution to that equation, I'd be asking you to do this. Solve that equation where x squared minus 1 equals 0. Where does the y equal 0? So we're going to look at quadratic formulas and factoring in particular in this video. And all of these approaches will find you x-intercepts, find you solutions, find you roots, find you solutions, and find you zeros. All of those things mean the same thing. You're doing the same processes, so it doesn't matter what they're asking you for, roots, solutions, zeros, or intercepts. You're going to be using quadratic formula, factoring, or graphing, and then, of course, using your graphing calculator as another option. Let's start off with looking at the quadratic formula. I'm not going to explain where it comes from in this video. If you'd like to know more about the quadratic formula, then check out the quadratic formula video. So we're going to be using x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And as soon as I've written down the formula, I want to figure out what a, b, and c are. Remember, those are the coefficients of the various terms in the quadratic equation. A is going to be the coefficient of the squared term, so a is 1. B is the coefficient of the linear term, b is -2. And c is the constant term, in this case it's -15. And now we'll just plug all that stuff into the quadratic formula. So x equals the opposite of -2 plus or minus the square root of -2 squared minus 4 times 1 times -15 all over 2 times 1. And I think I'm going to look at the discriminant first. Remember, the discriminant is the stuff under the square root sign, so what the value of the radicand is. And if I look at the discriminant, it's going to tell me how many solutions I should end up with, 1, 2, or none. So let's take a look at the discriminant. See, the square root 2 squared is 4, and -4 minus a -15 is a positive 60. So the discriminant is going to be 64. It's a positive number, which means that there are going to be 2 solutions which of course means that there are two roots or two x-intercepts or two zeros. They all mean the same thing. And having figured out the discriminant, the rest is pretty straightforward. Negative 2 is a positive 2, plus or minus the square root of 64. There's the discriminant, all over 2 times 1 or 2. The square root of 64 is 8, so 2 plus or minus 8 all over 2. And let's go ahead and finish this up. X is going to be equal to 2 plus 8 divided by 2, and x is also going to be equal to 2 minus 8 divided by 2. 2 plus 8 is 10, divided by 2 is 5, so there's one of my solutions. And 2 minus 8 is negative 6, divided by 2 is negative 3, and there's my other solution. So this graph would cross in two places on the x-axis at 5 and at negative 3. And if I take 5 and or negative 3 and substitute them back into the original equation, I am going to get numbers that work when y is 0. So that's using the quadratic formula. Quadratic formula always works. Factoring, the second method, doesn't always work. It might not be an easy equation to factor or a possible equation to factor. It is going to work in this case. To factor, I want to rewrite the x squared side of the equation in terms of its factors. This is a trinomial. So when I'm factoring a trinomial, I'm looking for numbers that will multiply to give me negative 15. And then add or subtract to give me the value of the coefficient of the linear term. Add or subtract to give me negative 2. So let's list out numbers that are factors of 15. 1 and 15, 3 and 5, and I think that's it. And because it's a negative 15, one of those factors needs to be positive and one has to be negative. It looks like I'm going to use the 3 and the 5 because I want them to add or subtract to be a negative 2. And if I want them to be a negative 2, my 5 has to be negative and my 3 has to be positive. So 3 times negative 5 equals negative 15 when I multiply. Positive 3 plus a negative 5 equals negative 2 when I add. Now I'll just substitute those back in. So y equals x plus 3 times x minus 5, and then write two equations. X plus 3 equals 0, or x minus 5 equals 0, which means x equals negative 3, and x equals positive 5. Which of course is the same as the answer that I got in the last way, which is a good thing. If I got a different answer, then I probably made a mistake. So you're probably thinking, why would I go through the trouble of using the quadratic formula? This factoring was so easy. Well, if it's really easy to factor and you can see your way to doing it, it sure is. Simpler, shorter, way more direct. But sometimes you'll get equations that are either difficult to factor, impossible to factor, or you're just not sure whether they're going to factor or not. And in those cases, the quadratic formula is going to work no matter what. So factoring works sometimes works, but the quadratic formula always works. And that's why it's something that people spend a lot of time memorizing, programming into their calculator, learning why and where it comes from, because the quadratic formula always works. Two more things I want to talk about in this video, but pretty short ones. One is if you can graph the equation by hand, you can just look to see where it's crossing, and if you have pretty decent values, that'll be easy to do. So in our case, if we had graphed that equation, we would have seen that our graph crosses at -3 and at 5. So no matter what method we chose, table of values or whatever, we would be able to see that it's crossing at those two places, and that'd be a really easy way to figure out what the solutions were. And the last method is using the grapher to calculate the zeros, or by going to the table on the grapher to see where y is equal to 0, what your x value is. And these we will do together, but you can also look online. So if you Google TI-84 and then zeros, you'll be able to find a lot of sites that will guide you through how to use your grapher to figure out what the zeros are. And if you don't want to do that, then hang on till we're together again and I will show you myself.